Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this GFG problem of the day, sorting a linked list using insertion sort. So guys, here we are given a singly linked list and we have to sort the list but with using insertion sort algorithm. So guys, in this video I will tell you to how can we sort the given linked list in without using any space in open space and in just on operation. Okay, so let's see. Here we are given n means the basically the size of the linked list. This is the linked list and we have to output the sorted linked list. Here n is equal to 7, linked list given this, so sorted linked list is equal to this. So basically first of all we will try uh, what is insertion sort. Okay, what is insertion sort? Insertion sort. Okay, so in insertion sort in an array, what we do, like if this is our array and this much part of our array is sorted, it is sorted, and we are at this ith index. Okay, then we compare it with its previous element, and when we go to element j whose value is has then or is equal to I, then we stop our loop. As well, what we do, we swap our j and I, we swap our j and I and decrement I by 1. Okay, I think you all know this. Okay, these are two steps. We stop here, this is stop when we stop. Okay, this is continue part. Okay, now why we are decrementing, like if suppose if our j is greater than I, so I just make it j, I put out I my here, and I just put out my j here, and now I will have to check this with this, so I will decrement my I, so my I is this now. Okay, so similarly same functionality we will use for linked list as well, but how I will tell you. Just give me a second. So guys, and in linked list you can see the time complexity n square, which is equal to the time complexity of insertion sort. Okay, but in linked list what we do, because we cannot traverse the previous element, but here we can traverse the next element. Okay, so here if we are index number I, suppose if we are our current node is equal to this, then we will compare it with all the previous nodes, and if we found a node with value greater than 9, then we will, like if here suppose it is equal to 17, then I just make it here, I just put it here. Okay, or like here it is 2, then our 2 will come in front. Okay, so similarly we will start from the starting node, from this node, this is our starting node. Okay, and we will sort our list first of all this, then sort this much. Okay, one by one step we will sort our complete list. Okay, so now I am going to tell you the approach. Now guys, what we are doing, just a minute, but I think, okay, so guys, now this is very helpful for us. Okay, so now guys, what we did, our space will reduce. So okay, okay guys, so now here, so what we can do, we are taken three variable temp is our head. So initially of this I can put out this, like this is our temp. Okay, and we take a variable current. Now current is this because single node is always a sorted node in its own. Okay, single node is always a sorted node, so we take it as sorted and do work on after first node link. Okay, after first node. Okay, so we will sorry, this is our current node. Okay, and our this much list is sorted as of now, and we take a previous node. This is not important to take, but I am telling you why I am taking. Initially previous node will represent as the node to in previous to our current node. Okay, I will tell you why I take it. It is not compulsory to take, but I take it for today reducing the time limit. Okay, so now we are running while our car means we have any node left in our node, it will stop here. So now what we are doing, and we are initializing temp with head, because you can see we are doing some functionality with temp in our each operation. Okay, so this is our while loop. Basically in our while loop will contain of three steps basically. Now what is first step? First step is the step where our current data, like suppose if our linked list is like this, linked list is like this is our linked list. Okay, so this is our previous, this is some more list. Okay, suppose this is our temp starting node, this is our current. If the our current data is greater than or is equal to our previous data, then we don't need to traverse whole linked list, because we know this linked list is sorted and this is the greatest element, this is the greatest value element in our linked list, and this current node have value greater than this. Okay, then if we just add this element and we can continue, because we know if this is sorted and this is greater than this and it is coming fast, so our this list is also sorted. Okay, so what I am doing, if my current data is greater than or is equal to my previous data, then I update my previous. So now my, like suppose this is next node, then my P became this, my P became this, and my C became this. Okay, C move one step, C move one step, and P move one step. In each iteration it will happen. Okay, I hope you all understand it what I want to say. Okay, so first step we had cover this first if condition. If this is, then we just use continue, else while. Else while what, which one condition I am writing? Suppose if our temp data, temp is starting node, this T is temp data means starting node. Okay, then means starting node, or you can say it as head node also. Okay, if our temp data means our starting data is greater than our current data, like here you can see in this much list. Okay, our 5 is greater than 2, it means our current nodes should come in the starting. Okay, so here what we can say, our linked list will start from 2 and continue with 5. I am telling about this linked list. Okay, and then it will continue as its own according to sorting order. Okay, now our linked list starting with 5, but it will start with 2. Okay, so this one sorting we will handle in this if condition. Okay, so here, but uh, just wait a minute. Okay, so here what we are writing, uh, so this is our linked list. Okay, so this is our linked list. Suppose this is our temp node, this is our previous node also. Okay, this is equal to 5, this is like this is our current node containing value 2, and this is our next node means 7. Okay, C current next. Okay, here T means temp, P means previous, C means current. Here T is temp, C is CUR current, P is PREV previous. So what we are doing, suppose just see, I am making some new connection now. So first of all what we are doing, we are putting our current dot next in my previous dot next. Okay, so what we are doing, in my previous dot next I am putting this current, I make it some more clear. I putting current dot next. It means it will not point to this now. It will not point to this now. Okay, I cut this step. Now in second iteration, in second step, what I know, in current dot next, in current dot next, what I am putting temp. Okay, in current dot next means my current dot next will point to this T. Okay, means 5. Okay, so now I can say this step is also cut. Now, in my head and temp, I am updating my head as well as temp both, because my temp is equal to head and head is my similarly the starting of the node. Okay, and in head, like suppose there is a variable, constant variable head, which I am not changing, which is point to this node. As well, what is the changing in our node? It will not matter. Our head will also always pointing to the start of the node. Okay, so I am pointing, and what I am doing, I am updating my head and temp with my current, means my temp my temp will now point to current. Okay, so our temp is point to this, but I can say yes, this is right. Our temp is now point to this, so now this will also cut down. Okay, this will also cut down, this relationship also ends. And in my current I update with my previous dot next. So now my c point to this now, but now it will not, it will point to previous next. And what is previous next is equal to current next. Okay, so this is my updated linked list. How can I write it? So we have this variable t, we have this variable c, we have this variable c because previous, and we have this variable c, our current variable. So what is our current idea, our current point to 7? Our current point to 7, I am taken this node. Now my 2 point to my t. Okay, so now I am updating my temp and current to cur. Okay, so my temp, just wait a minute, but I am current next. Okay, so it is my 2. Just stop this for a minute, take this as starting node. Okay, 2. Now my current dot next is equal to temp, so my temp is equal to 5, so it will point to this 5. Now it will point to this 5. Now this is point to my 5 now, then this point to my 5, and 5 point to this 7. Just a minute, 5 point to this 7, 5 point to this 7. Okay, oh, this is c, I am updated this c, this is my p now. Okay, so sorry, so the temp point to 2, you can see here, temp point to 2, temp point to 2. Okay, 2 point to this 5, 2 point to this 5, you can see this is the current node. And p is this node, p, and this node is updated by my this. So here p will come, here p will come, because I am not changing the address of p. My p is constantly point to this particular node, but what I am doing, I am putting this in starting. Okay, and make temp to point this. Okay, so what I am doing, I just remove this node, put in the starting, temp point to my this node, take out p, so p point to my this node, so p point to my this node, and make out current will point my this. Okay, so basically I have three nodes. So what I am doing, I am taking this node, put in the starting node. Suppose this is my previous node, and this is my temp node as well. Okay, this is my current node, and this is my current next node. I put out this, my p node that point to this, I make it, because I cancel out this. So now my the node point to this, but my previous node remains same. Okay, because only my current update, because if I remove it, so for this the previous node is also the same. Okay, so if I have three nodes, suppose this is current next, this is current, this is previous. Now for this the previous node is this, but, and for this the previous node is this, but you can see I am erased this node. So now for this also my previous node is this. Okay, so this is what I am doing, try to update this node, come to in a starting node, all the linked list remains same, previous node remains same, but what happens, my previous node now point to this, means the previous node of my current next remains as previous same. Okay, we will not update previous node. You can see I just update the previous next, not the previous node. Okay, I hope you all understand. So now we have sorting this much list, and what is our link list as of now? 2 and 5. Okay, and our current, it is our p, it is our t, our temp, we will point out our temp as well. Okay, now it is equal to 7, this is our previous node. And as you can see, oh, I don't need to write it here because the value also updated accordingly. Okay, so Okay, so here this is my T node, this is my C node. 0.27. Okay, and as we compare it, our current value greater than or is equal to previous value. I update my previous. So now I update my previous as well as current. So now this is my previous value and my I put out current. So our this much list is sorted, and I now check for this. This is my current next. So this is my current dot next is equal to 9. Here it is C. Similarly, this condition will true. Similarly, this condition will true. So here my current point to current next, current point to current next. This is previous. I can erase it. So this is previous for me. Now this is current for me now, and we can see our this much list is sorted. Now we have current as 3. So now our this step will work out. Okay, because our current element is not greater than our previous. 3 is not greater than 9. Our current element is not less than 2. Okay, so means it will come in some node between this. So what I am doing, I am searching a node. I am searching for a node in my linked list, in a linked list that contain an infinite number of a finite number of node. I will found for a temp t whose next contain value greater than my this value. Okay, so what I am want to say, this is a value which is less than 3. This node has a value that is greater than or is equal to 3. It means here in between of this I can put out my 3. In between of this I can put out my my 3. So my 3 will come here, and I update my current to this, and as I cut this, so my previous remains same. Okay, so similarly we are find I am finding here this is my current linked list as of now. Okay, so can I copy this? I just wait a minute. Control C, Control V. Yes, I can copy it. So just a minute. Okay, so this is my linked list as of now. Now I am just changing the color, checking it true. I am changing while my temp next value is less than current value. Temp is this. Temp next value is less than this, is less false. Here 5 is greater than 3. This same. I will take blue. It is greater than 3. So I found a node. Okay, means our 3 will come in between 2 and 5. Okay, then what I am doing now, take on this. This is 2. This is 5. This is 7. This is 9, and this is 3. 3, and after 3 we have any nodes? Yeah, we have 15. Okay, so our after 3 we have a node value 15. So this is our current node. This is our previous node. This is our temp node. This is our temp node. Okay, and suppose if the value is equal to 6, then I will run my this while loop for once. Now our temp will stop when our temp is equal to this, because temp dot next is equal to 7, which is greater than 3. So our while condition became false and our temp will come here. Okay, but it doesn't matter. Now what I am doing, I am updating the next of my previous to chi dot next. Means now I am updating the linked list. Now the next of my linked list, I can point to what happens. The next of my linked list point to this. Okay, now in second step, my current dot next is equal to temp dot next. My current dot next, my this is my temp. My current dot next is point to temp dot next point to 5. My temp dot next point to current. Okay, so now I can say this is also cancel. My temp dot next means my temp dot next point to this, or what I can say, just a minute, what I can say, this is a independent node now. Okay, so here there is a node 3, here is a throw node 3. Okay, whose next whose next point to 5, and our temp next point to 3. Okay, so here, and our current is equal to previous dot next. Okay, now this is my current, but now what is my linked list? 2 point to this 3, 2 point to this 3, 3 point to this 5, overwrite it, 3 point to 5 point to 7 point to 7, 7 point to 9, 7 point to 9, and 9 point to 15, 9 point to 15. Our, this is our previous, this is our temp, and as of now this is our current, this is our current. But what I am doing, I am updating my current to previous dot next, because each node has an address, and our current will contain the address of 3 as of now, because only the next pointer updated. So now my current pointer is also update now. How it is update? My current pointer will now point the next of my previous dot x is equal to 15, and this condition, our current value is greater than or is equal to 15, so we just update my current point to null now. This is equal to null, my current point to null, my p point to p, p point to current. So p point to this, current point to null is continue, while current is null, so our loop will end, and we just return our head. And as I tell you, our head always contain the address of starting node. This is our head. So this is our sorted linked list 2, 3, 5, 7, 9, and 15. Okay, so I am just showing you by taking the input. Now what is our input? This is our input, and number of nodes 1, 2, 3, 4, 5, 6, and 5, 2, 7, 9, 3, and 15 are the value. So you can see it is running compilation here. Just a minute. Oh, sorry, I write it as null. Now can it? I think I updated the same. Yes, you can see this is the given test get updated. Now I will test for a custom input. The error I am writing it as well, because yes, you can see the output is same for this 527, 527. Output is 25235, and this is my, where is my final year, 235 79 15. Okay, this is our updated linked list. So I just try to submit it. So guys, you can see all the 20 test cases pass out. Time taken is 0. That's because we doing it in n square. So time complexity is square, and space complexity is O1, because there are many who can do n log n by storing it in vector, but it will take a O(n) time. O(n) memory space, but I'm doing it in O1 memory space. Okay, constant memory space. So I hope you all understand it, you all like it. I explain you all the how we will do, what functionality we will use, how we will use update linked list one by one. Okay, and in final step we will get the same updated linked list. Okay, the same updated linked list. So guys, I hope you understand it, you like it, and if you still have any doubt, then just comment out. I will try my best to explain you, and in that you can like the video, subscribe the channel, and check out my channel for more GFG and LeetCode daily problems. So thank you for watching this guy, and stay tuned.